Hi, welcome to Sachin Study Tech. Today topic is operators in Java. So operators in Java are a special symbol that perform operations on variables and values to produce a result. Now these are the operators supported in Java. So arithmetic operator, relational operator, logical operator, assignment operator, unary operator, ternary operator, bitwise operator. Now we can discuss one by one. Here arithmetic operator. So addition plus subtraction, multiplication, division and modulations. So for example, you can take the value here. For example, a equal to 7, b equal to 2. Now we have to perform a plus b. You know already a plus b, that is value is, so can represent a plus b, right? Here the c equal to, for example, c equal to a plus b. What is the c value? Here 7 plus 2, that value is 9, right? For example, 7 minus 2, like that you have to perform, and 7 into 2, right? 7 minus 2 and 7 into 2. What is the value here? 7 minus 2, that value is 5. 7 into 2, that value is 14, right? Here 7 by 2, 7 by 2, so that value is 3.5, right? Here the modulation operator, 7 mod 2, okay, this operator, so 7 mod 2. So here what is the difference between these two operator? Have to see here. So in division, 2 3s are 6, here it is a 1. So you can see, for example, if you want to consider here only integer value, right? 7 by 2, the value, integer value is 3, that is the quotient. And what is the 7 mod 2 value? So the 7 mod 2 value is a remainder, that is 1. Okay, so this is the difference. So here 7 by 2, the result is a quotient. Here 7 mod 2, the result is a remainder. So this is the remainder. So this is the example for the arithmetic. Now we can see the logical operator. Now you can see the relational operator. So this is equal to, comparison, okay, double equal to, here it is a not equal to, less than, and a greater than, less than or equal to, greater than or equal to. Now for example, a equal to 5, b equal to 6. Have to compare a double equal to b. Okay, so 5 double equal to 6, it is not true, so it is a false, it is a false. You can print the false, right? So for example, a not equal to b can represent like this, a not equal to b, s, a not equal to b, it is a true, so you can print the true here. For example, here less than or greater than, a less than b, is it true or not? 5 less than 6, right? 5 less than 6, so it is a true. So the minimum value is 5, right? Here you can see the greater than. So for example, b greater than a, okay, 6 greater than 5, it is also true, right? Less than or equal to, okay, 5 less than or equal to 6, so it is a true. Okay, 6 right here greater than or equal to 5, okay. Now then, so these are the relational operator. Now we can see the logical operator. After that, after seeing all these operator, have to write one simple example program, Java program. Then you have to understand that logical and, logical or, logical not. Here you can see the logical and. So what is the logical and? For example, here you can see a equal to 5, b equal to 6, right? For example, a greater than 2, logical and b less than 10. Okay, you can see this is the statement, a greater than 2. So a greater than 2 means the 5 greater than 2, so it is a true. And logical and, okay, logical and, here you can see b less than 10, so that is 6 less than 10, it is also true. So both the condition true, the resultant is true. Now here true and true, that is true. So that means you can see already, you know, in truth tables also. For example, here you can see AND operator. For example, here it is a PQ, okay, P and Q. If you want to perform like this, it is a false, here it is a false, for example true and false, false and true, like this true and true. Here the and means both the statements true, then only result is true, remaining all the cases false, right? Here you can see, okay, right? Here it is a logical or PRQ, like for example in logical OR, here you can represented here it is R. So if any one of the condition is true, the resultant true, either this one or this one. Okay, now how to represent? It is a false, false, false. So anyone is true, true, anyone is true, true, anyone is true, is true. So this is the R operator. Like how to perform? Not means, for example here A equal to true, A equal to true, not A means false. Okay, so that is the operator. Now we can see the assignment operator, like A equal to 5. So this is single equal to is called as a assignment operator. Assignment operator. So how can represent here, for example A equal to A plus 5. Here also you can write this statement here. You can write this statement A plus equal to 5. So both are same. So A plus equal to 5. Shorthand notation you can write. Here also same thing, minus, and here also same. Here you can see equal to, for example here it is 2. So like here it is, for example A star equal to 3. Like you have to minus equal to, for example 2. Like how to perform like this assignment operator. So single equal to is a assignment operator, double equal to is a comparison operator. Here it is a comparison operator, right? So these are the assignment operator. What is the unary operator? So unary operator means plus and minus is a unary operator. Why it is plus and minus? So here it can represent, for example plus 5 or plus A. So it represents the positive value. Minus B, it represents the negative value, right? Minus 6. Like that it represents positive and negative. Unary operator, what is meant by unary and binary operator? Unary operator works on only one operand. Okay, so for example here you can see A plus B. So this is the operator, plus is a arithmetic operator, right? So A and B are operands. Okay, plus is a operator. Plus is a operator. The operator in between two operands is called as a binary operator. This plus is called as a binary operator in this case. Okay, so we have two operands is there. For example here you can see here the same plus A. That means it can represent the positive A. So it is a unary operator. This plus is a unary operator. Same plus operator you can use in between two operand. It is called as a binary operator. The same plus operator you can use only one operand. Here it is called as a unary operator. Like here also minus also same thing. Okay, it can represent unary operator, and also if you can see this is A minus B, it is a binary operator. Like okay, so here the unary plus plus and minus minus. What is the meaning of that? For example A equal to 5. So what is the meaning of A plus plus? What is the value of A plus plus? Okay, if you want to print A, so this is the post increment. Okay, you know, for example B equal to A plus plus, B equal to A plus plus. What is the value of B? What is the value of B? Now you can see if you can print the A, the value is 5. Okay, B equal to A plus plus. So what is the value of B? So first you can assign the value. What is the value is there here? 5. So can assign the value to the B. So if you can print the B value is 5. Okay, what is the value of A? Okay, just a minute, you have to see what is the output of this program. Now in the same way here it can, for example B equal to plus plus A. So this is called as a post increment. So this is called as a pre-increment. First incremented the value, then assign the value here. So what is the 5? 5 plus 1, that is 6. So 6 is assigned to B. So A is 6, B is 6. So in this case you can see B is 5 but A is 6. Okay, B is 5, A is 6. In post increment, this is post increment, this is pre-increment. Like here for example you can see A equal to 5. Okay, so B equal to for example A equal to 6, you can take A equal to 6. Okay, minus 6. What is the meaning of? This is the pre-decrement. This is the meaning of pre-decrement. First decrement the value, okay, right? You can take minus a. First decrement the value, so that means decrement by 1, so the value is 5, so 5 is assigned to B. So what is the value of A? A is 5 and B is also 5 in this case. For example, you can see A equal to 6, so B equal to A minus minus. A minus minus. First you can assign the value, later you can decrement. So this is the post decrement. So first you assign the value, then decrement. So what is the value of B here? So value of B is 6. What is the value of A? A is 5. In this case A is 5. Now you can see the example program, then you can understand. Here you can see that is the unary operator, all these things. Now you can see the ternary operator. Here also it represents, it is also unary operator, right? Okay, for example here it is, you can represent it is a true, that means it is a false. Okay, for example I am declared boolean for example A equal to true, A equal to true. So for example if you can print, here it is tilde A, here it can print this. What is the value? Not A, that means it is a false, right? It can print the false. Ternary operator. What is the ternary operator? Just you have to see. Ternary means, okay, it works on 3 operands. It works on 3 operands. That is the ternary. 3 operands. Like for example here you can see A equal to 5, okay, B equal to 6. If you want to print the minimum value, right? You can see here it is a C equal to, so A less than B. If it is true, then A is printed, A is assigned to C. Otherwise if it is false, okay, B is assigned to C. So this is the ternary operator. So here this is the operand C and A and B. So 3 operands is there, 3 operands. It work on 3 operands. So this is the operator. Okay, so that's why here you can see 5 less than 6. Okay, the condition is true. That means A is assigned to C. That is, you can print the C. If you can print the C, what is the value here? 5 is the value. Okay, for example you can see it is a 15, right? So you can see 15 less than 6. Okay, 15 less than 6. Is it true? So it is a false. Then B is assigned to C. So what is the C value in that case? That C value is 6. Okay, this is the ternary operator, right? Now have to see the bitwise operators. This is the bitwise OR, exclusive OR, XOR. Here it is a complement, right? It is a complement, tilde, it is a complement. So it is a left shift, it is a left shift. Okay, now we can see that right shift, here it is a right shift, right shift. So here unsigned right shift, unsigned right shift, it is also supported in Java, unsigned right shift. Okay, now we can see the one by one, then you can understand. Now what is the AND? For example here I am taking A equal to 5, B equal to 6. Okay, now you have to print A and B, A and B. What is the value of C? What is the value of C? So this is a binary operator, that is a bitwise operation performed on binary values. What is meant by binary value? Then binary value consisting of 0 and 1. Now first you can convert this 5 into this decimal value into binary value. So what is the 5 here? 0 1 0 1. So this is a 5. Okay, right here 6. So you can perform the AND operation. Now it is a 6, that is 0 1 1 0. So how we can convert it? That you can see here it is a 5 divided by 2 here, 2 2s are 4, remainder is 1, and 2 1s are 2, remainder is 0. So you can write here, in this case you can write 1 0 1, right? You can write the 1 0 1. Like that you have to see here 6 is converted into binary, 2 3s are, so the remainder is 3, So 2 2s are 2 1s are 2. So remainder is 1. So here 1 1 0, right? 1 1 0. Okay, so in 4 bit I am represented here 0 1 0 1 0 1 1 0, right? What is the and means both the inputs are same, that is 1. So 1 0, that is 0, 0 1, that is 0, 1 1, that is 1, 0 0, that is 0. So what is the value here? Just if you want to print the C, the value is 4. Okay, you can print the 4. Okay, like here for example 0 1 0 1, here 0 1 1 0. How to print R? Bitwise R. Okay, so what is the R? R means 1 0, that value is 1, 0 1, that value is 1, 1 1, that value is 1. Okay, 0 0, that value is 0. Only 0 0 case 0, 1 1 or 0 1 or 1 0, the value is 1. The resultant value is 1. So this is the R. Now you can see the tilde. Now for example here A equal to 5, you can print here the complement A. Here you can see what is the value. That means it is represented like this here, A plus 1. So minus A plus 1. What is the value? 5 plus 1. So bracket is the high priority. First you can evaluate this expression within the bracket. That value is 6. Here you can put the minus. So what is the value of this one is minus 6. Okay. Now what is the left shift? What is the left shift and right shift? What is the shortcut for that? You can see for example here you can see A equal to 5. Okay. B equal to A left shift, A left shift, for example 1. That what is the meaning of that? Here you can see first you can represent it in the binary form. Okay, that value is 0 1 0 1. Okay, this is the 5. So left shift means here the bit is shifted left side. Here it can see the 0, here it can see 1. Okay, here it can see the 0, here it is 1. So here this is the empty position. You can put the 0 here. So what is the value here? You can see what is the value? 1010. The value is 10. Why it is 10? So you can see 1010. Here 0, there is no value here. Most significant bit is 0. There is no value here. So if you can see this, this is the binary number, right? Here it is converted into decimal number. How it converted? 0 into 2 power 0 plus here it is 1, 1 into 2 power 1, right? Here it is a 0, and 0 into 2 power 2 plus here it is a 1, 1 into 2 power 3, right? Here it is a 0 into something 0, and plus 2 power 1, it is a 2, plus 2 power 2 here into 0, that is 0, plus here you can see 2 power 3, that value is 8. 8 into 1 8. So you can see the 8 plus 2, that value is 10, right? Here the value is 10. So what is the shortcut for that? So what is the shortcut? For example, you can shift the one bit is shifted left side. For example, if you want to bit 2 bits is shifted left side 2 bits, then what is the value here? What is the shortcut for that? You can see. So what is the actual value? Actual value is 5. So you can write the actual value into, so it is performed on bitwise numbers. Okay, binary numbers. Bitwise operators performed on binary numbers. What is the binary base 2? So binary base is 2. So you can see the base is 2. So how many bits shifted left side? Only 1 bit. So you can write 2 power 1. So 5 into 2 power 1, that is 10. So the value is 10. Right here, for example, if you want to shift 2 bits left side, that is 5 into 2 power 2. That is 2 power 2 means 4 into 5. That value is 20. Like that, how to print. So for example, okay, you can take the, here it is A equal to 5. You can consider B equal to A. This is right shift. This is the right shift. 1 bit is shifted right side. What is the value of B? So what is the value of B? Now you can represent it here. It is a 5. So shifted right side. Okay. So for example, here you can see it is a 5, right? How to shift it here? 1 is shifted here, 0 is shifted here, 1 is shifted here, 0 is shifted here. Simply can shift this one bit. Here the vacant position is there. Just to add 0 here. What is the value? So what does the shifted in right side? The shift is discarded. This one is discarded here. So what is the value here? Okay, 0010. That value is 0 into 2 power 0 plus 1 into 2 power 1. So the value is 2. Okay, this value is 2. So what is the shortcut for this? What is the shortcut? Here you can see in left shift you can apply here. In left shift you can apply how many bits shifted left side. This is the, okay, just you have to write. So actual value into 2 power how many bits shifted left side. For example, in right shift you can write 5 by 2 power n how many bits shifted right side, right? So this is the actual value. For example, here, for example, if you want to 2 bits shifted right side, so that means 2 power 2. So what is the value? 5 by 4. What is the value of that? Here the value is 1, right? Likewise you have to perform. What is the meaning of this one? It is a unsigned right shift. So what is the difference? What is the difference? For example, I consider 5. For example, in this case, b equal to a right shift 1 or 2. For example, I am giving 1 here. What is the output? You know already. What is the output here? You can see. That means 5 by 2 power 1. That is, okay, what is the value here? The value is, you can see already, 1. The value is 1, right? What is the value here? You can see that value. So 101. Okay, so 1 is shifted. That value is 2, right? It is not 1. The value is 2. Okay, right? For example, here also you can apply the same thing. A. Okay, the value is also 2 in this case also. Here right shift, unsigned right shift this is. Okay, so it not preserved any sign value, but in this case it can preserve the sign value. In this case it can preserve the sign value, either it is a positive value or negative value it can represent it. But in this case, whenever you can use this type of unsigned right shift, so it is not preserved the sign value. What is the meaning of that? For example, here it is a positive value, both the outputs are same. But in case you can take the a equal to minus 5, what is the value here? So here it represented here the negative value is represented the 2's complement form. So for example, int is a 32 bit, int is a 32 bit. So you can represented this 5 is, so minus value here you can see, sign bit indicates 1 indicates the negative value, 0 indicates the positive value. Already you know, 1 indicates it is a negative value, 0 indicates the positive value. Now you can see what is the value, a equal to minus 5. So just you have to apply. Okay, so a right shift 1. So what is the value here? You can see, first you can represent it in the 2's complement form, this minus 5, that is in 32 bit you can represent it. So minus indicates the 1 here. So you can write up to 8 ones, and you can write 8 ones, and you can write 8 ones, and you can write 1 1 and so on. Here it 5 means it is a 101. Okay, right? So it minus means it can represent the 1, right? So after you can perform the 1's complement. So these all bits are zeros, right? 0 here, 0 0 8 zeros, and 0 8 zeros, and 0 8 zeros, and 0 and 0. Here it is, you can convert it into, here it is a 0 1 0, right? So what is the value here? So you can perform the 2's complement. Just you have to add 1. Okay, you can perform the 2's complement. That means you have to add 1. So what is the value here? It is 0 1 1. Okay, so this is the value. Now for example, in the case of we can perform here, you can see what is the value in this case, unsigned right shift. So here it cannot represented anything. Okay, the sign bit is not represented here, unsigned right shift. That's why here taking, here it is 80, and here it is 80, and here it is 80, and here it is, okay, right? This is the number 5. Now it can perform the 1's complement now. after this you can see the result here. Okay, right shift means here you can shift it right here. So what is the value? Now we can check here also ones complement, that means here all ones, 8 ones and 8 ones, here 8 ones, and here also like here 0 1 0, and 2's complement means here all ones, here 1, so can add here it is 1 1, right? Here all bits are 1, so all bits are 1. Now we can print this value, so very large value it can print. Okay, so after 2's complement you can shift it 2 bits on right side, just you have to shift 2 bits. So then what is the value of the remaining one? Okay, now you can see the value here, and also what is the XOR value here, exclusive OR. Now you can see the exclusive OR. What is the exclusive OR? A equal to 5, B equal to 6. What is 0 1 0 1 and 0 1 1 0? Here you can see what is the XOR. XOR means 0 0 is 0, 1 1 is 0. Remaining case 0 1 is 1, 1 0 is 1. Okay, both the inputs are same, the result is 0. Okay, 1 1 is 0, 0 0 is 0. So remaining case 0 1 1 0 1 1. So this is the output. Now how to see the simple program, then you can understand what is the operator here, what are the operators we are discussed here. You know, here for example int a equal to, for example you can see one simple program, then you can understand that int a equal to 5. Okay, then b equal to 6, then c equal to int c equal to a plus b. Just you have to print that c equal to a plus b, just you have to print c value. What is the value of c? Okay, now you can save this program. Now you can compile this program and you can run this program. Now what is the output here? So 5 plus 6, that is the output is 11, right? If you want to print the some message also, for example addition, if you want to print addition, okay, colon, have to print that, then you can put the plus here. So this is the append, that means here it is a string, in double quotation it can print, so it can print the value, right? Just have to save this program. Now have to compile this program. So what is the output? Here you can see what is the output, addition 11. So here it can print the 11, here you can see the addition. What is the message is there within the double quotation, you can print as it is here, addition colon, then you can print the value here, it is 11, right? If you can print the minus, or here for example if you want to print like here I am taking b value is 2, now have to see a by b. So what is the value here? The division, right? How to write the division? For example you can print the c here, directly can print the c. What is the value? Now how to compile and you can run that program. You can run that program. What is the value here? It is a true. 5 by 2 means 2.5, but here it can consider integer value, so that's why it is a 2, right? For example here you can see the modulation operator. What is the value? So it can gives the remainder, already know it can gives the remainder. So what is the remainder here? Just you can compile this program, just you can run that program. Here you can see the remainder is 1, right? The remainder is 1. Like that you have to perform all the arithmetic operations. Okay, now for example here in this case you can see what is the value here. Okay, a less than b. For example in this case it can return the boolean. Now for example in c it can return like here for example you can see here it is a less than b. So what is the value here? So in C it is okay, but it return either if it is true it return 1, if it is false it return 0, but in this case Java it returns true or false. So it requires the boolean data type. Okay, C is a boolean data type. So if you can check this, just have to compile this program. Now what is the error here? You can see incompatible. incompatible type. Boolean cannot be converted to integer. That means here a less than b, it return true or false, that hold in C, but C is the integer type. Just you have to declare this type is a boolean, right? Boolean. So you can print. Now you can see that what is the output here. Just you have to compile. Okay, there is no problem here. So you can see the output here, it is a false. Okay, boolean, it is a false, right? How to print true or false like that. For example, you can give here it is a true, so less than, here it is a greater than. Then you can see what is the output here. You can see the output is true. Like to how to perform. For example, I am printing here, it is a okay logical AND. So a greater than 10 and logical AND b greater than b less than, for example I am using here b less than okay 15. So what is the output here? You can see a greater than 10. Okay, this is false. So once, for example, in logical and performance, first expression is false, need not to check the second one, because both the condition is true, then only true. For example, in our case, in logical OR, if it is first expression is false, then you can check the second expression. If first expression is true, need not to check the second expression in the case of logical OR. Now what is the output in this case? You can see what is the output. Okay, you can see the output here, it is a false. Okay, for example, if any one of the condition is true, as here it is a condition is true, now you can use that logical OR here, logical OR. Now what is the output? You can see what is the output. You can see the output here. So what is the output here? It is a true. That means if any one of the expression is true, the resultant is true, that is R. Okay, you know the not means, for example, you can put the not here. If it is true, then it can gives that here just the whole expression is it is true, but not means it is a false, right? You can see the output is false. The output is false, right? This is the logical AND or not. Okay, if you want to print the logical values, right? Okay, next this is the assignment operator, a equal to 5, right? Okay, now you can see for example, int b equal to, okay, like here it is a plus plus. So you can see the output here. You can see the output. What is the output here? You can see. You can print a, what is the value? You can print b, what is the value? Unary operator, right? Okay, this is the post increment. What is the value? Just you have to clear screen. Now you can compile this program. Okay, now I can run this program. What is the output here? The first a value is 6 and b value is 5. Okay, just if you want to print also a colon, here you can print a colon, can print the a value, and you can see it is a b value, right? Just have to print like this. So can compile this. Here it is a plus a, right? Here plus b, you know already. Now you can compile this program. Now we can run this program. So what is the value? A equal to 6, b equal to 5. What is the meaning of that? So a equal to 5, just first 5 is assigned to b, so b value is 5 s, but a value is after incremented. So before incremented 5, after incremented here a is incremented now, so that value is 6. But b value, first you can assign the value to b. A Post increment means first you can assign a value to the b, then you can print the b value is 5. After that a is incremented. This is the post incremented. Now that is the value. Now we can see the pre-incremented, what is the value. Now we can see pre-incremented, what is the value. Now you can compile this program, just you have to run this program. Here you can see both the values a and b are 6. That means first incremented, then assign the value. So this is the pre-increment. First increment the value and assign to b. So that's why a is 6 and b is also 6. Like that here also, for example, you can see minus minus. Okay, post decrement, right? You can see the post decrement. Just you have to compile. You can run this program here. First save the program, then you can compile. You can run this program. The values are a equal to 4, b equal to 5. What is the meaning of that? So a value 5. So 5 is assigned to b. So that's why the b value is 5. Okay. Then after that a is decremented. That's value 5 minus 1, that is 4. Right? For example, you can see here it is pre-decremented. Pre-decremented. Now we can see the value. What is the value here in this case? You can check. You can compile this program. Just you have to run this program. What is the value? In the both the case 4 4. Okay, first decrement the value. That means 5 minus 1, that is 4. 4 is assigned to b. So that's why a is 4 and b is also 4. This is the increment and decrement, increment and decrement operator. Okay, now you can see the ternary operator. Okay, for example, you can see the ternary operator now. What is the ternary operator we are discussed? Right? A equal to 5, b equal to 6, for example, here. Then you can see the value here into c equal to here a less than b, question tag a colon b. So what is the meaning of that? You can see if the condition is true or false, 5 less than 6, the condition is true, then a is assigned to c. A is assigned to c. So you can print the c value here. You can print the c value. So what is the value here? You can print c. Just you have to change that. Now clear the screen. Now you can compile the program. Just you have to run that program here. What is the output? Output is 5. What is the meaning of that? Here a less than b, the condition is true. That means the first expression is assigned to c. So that is a value assigned to c. So that is 5. For example, here it can give a greater than b. Okay, then it is a false. 5 greater than 6, it is a false. Then b is assigned to c. Now b is assigned to c. What is the value of b? B is 6. That's why here you can see the value here. It is a 6. Right? You can 6. This is the ternary operator. For example, if you can print the value right, for example, a, bitwise and b. So what is the value here? Already we have discussed. What is the value? You can print the value here. It is okay. Next you can compile this. You can run this program. What is the value? Here it is a 4. How it is 4? We have discussed already. For example, if you can put the r here, bitwise r. So what is the value here? What is the value? You can compile, you can run. What is the value here? It is 7. Okay, right? How to XOR operator? What is the XOR operator? Already are discussed. Now you can see that XOR operator. Now we can compile this program. Just 0 0 is 0, 1 1 is 0. The remaining cases it is 1. So the value is 3. Right here, for example, in this case I am using 5. Right here, a left shift 1 bit is lefted, left shift 1 bit shifted left side. So what is the output here? You can see what is the output. Now you can see that output here. You can run that program here. What is the output here? You can see the value is 10. Why? 5 into 2 power 1, right? it is 10. For example, here it is a for example 2 times is shifted left side, 2 bits shifted left side. So have to see what is the output here, how to compile, then run that program here. 2 times shifted, so that is 5 into 2 power 2. 2 power 2 is 4. 4 into 5, 20, right? 20, the output is 20, right? Here now you can check, it is a, for example, right shift, what is the value? So you can compile this program. Now you can run this program. Now what is the output here? You can see the output is 1. That means 5 by 2 power 2, 5 by 4, that is 1, right? For example, here the 1 bit is shifted right. So what is the value here? You can see the what is the value. Just you have to run here also. So first you can save this program. Now you can compile this program. Now you can run this program. What is the output here? It is a 2. That means 5 by 2 power 1. Okay, 2 2s are 4. So the quotient is 2, right? For example, in this case, for example, I am using here unsigned right shift. So in this case also the same output. So in positive value it is the same output. If it is negative, what is the difference? You can see now. So the same output, here it is a 2, here it is also a 2. So that here it is, what is the operator here? It is a unsigned right shift, right? For example, here the -5. So what is the value? So I am using just right shift. Okay, first I am using right shift. What is the value? Now you can check, you can compile this program. Okay, you can run this program. What is the output here? -3. Okay, why it is -3? Already we have discussed. You can see that program. First this -5 is converted into 2's complement form. Then you can apply the here it is a right shift, 1 bit shifted right side. Then what is the value? You can see the value is -3. So negative, that means sign is preserved in that case. For example, in this case you can see what is the meaning of this one. Here it can print here unsigned, so sign is not preserved. In that case, what is the output here? Just you have to see what is the output. You can compile this program, just you have to run this program. So this is the output. Okay, large value is printed here integer. Why? You know already. Okay, the negative value it cannot preserve any sign bit. Okay, so that is the problem here. It is an unsigned right shift. Okay, so these are the operators supported in Java, like arithmetic operator, relational operator, logical operator, assignment operator, bitwise operator, increment decrement operator, ternary operator. Like these are the operators supported in Java. Thank you for watching this video. Later you can discuss in detail about remaining topics.